Hello, I'm Jordan Earls, the co-founder and lead developer of Qtum, as he said. Today I want to talk about basically how we can advance the smart contract ecosystem and basically what the next step is for all these smart contracts and dApps and everything. So first, just a quick spiel about what is Qtum. And Qtum is a proof-of-stake blockchain. It has smart contracts. It uses, right now, like the Ethereum virtual machine, so you can write Ethereum Solidity smart contracts in it. And it also contains a decentralized governance piece that basically allows us to control certain parameters of the blockchain without needing to fork for every minor change. And also, the entire platform is focused on mobile and IoT usage and basically bringing smart contracts to those lightweight devices. So first of all, like the current status of smart contracts it's good, but there's quite a few different problems with the space. For one thing, it's written in the specialized language Solidity, which is just very young and immature, and there's still, new bugs being blamed on the compiler like today. And as a result of that, security problems happen like very often in this space. And I think last year it was like $500 million or something lost in total due to smart contract bugs. And there's also, limited functionality as to what is actually possible to do with the current blockchain smart contract platforms that we have. For instance, you can't do anything computationally expensive or anything like that. And also new features on the platform, on Ethereum, typically requires forking. So they have scheduled forks that happen every however many months, but they basically use that opportunity to include new features. They can't really include things like new encryption algorithms or quantum-resistant hashing functions or whatever. They can't include that without actually forking, disrupting the entire ecosystem. Everyone has to download a new client, turn off their node, and everything else. So it's a lot of hassle to actually keep up with the current state of smart contracts. So one of the big things that we're trying to do basically is to make a new virtual machine that has old roots basically. So we're using the x86 architecture. That's the Intel i7 or whatever that's in your MacBook. That's the computer that you use or the processor that you use at your desktop computer. And so as a result of it being used in so many different places, it allows us to basically piggyback on a lot of existing tooling. For instance, with formal analysis and static verification tools, things that you use to find security problems in normal desktop programs, things that the military uses to basically check their code and everything. We're able to use that same tooling because we're using the same architecture, we're supporting the same languages. Basically, the only difference is that in the Qtum x86 VM, you're basically targeting Qtum operating system instead of Windows or Linux. And so with that, we plan on supporting C++, Rust, Go, and potentially Python, as kind of our main target for programming language support. And also, this whole VM and everything is being developed in the open. It's completely open source, and you can actually check the code that we have now. It's still really early, but we've been basically doing this out in the open from the very beginning, and we're hoping that other smart contract platforms actually integrate this, because I feel like this is a very good way of advancing the ecosystem, but it involves more than just quantum. So one of the big things with the whole x86 stuff is that we're designing a new database consensus structure that basically allows you to build what we right now call censorship-resistant FPV proof. And basically what that means is that you can have a light wallet, such as a mobile or IoT device, get a contract state and everything, and be certain that they are not being censored or anything. Because right now in Bitcoin, so kind of where the FPV protocol model and everything comes from is Bitcoin. It was originally described in the Satoshi white paper. And so basically this, the FPV proof is a way of like tying a transaction into the blockchain without having to download and verify the entire blockchain. The only major problem with it is that it's possible for a node to basically say, oh, I've never seen this address, I've never seen this transaction or whatever, and basically censor that data. And of course, you can go to multiple nodes and potentially get that data from other nodes that aren't trying to censor that. But like there's network segmentation attacks and things like that that can make that a serious attack vector. With the x86 VM, we're introducing basically censorship resistance on top of that. And so basically people will be able to use a light wallet, check the blockchain, and basically be certain that they're not missing any data. That if they provided me some data and it's they could potentially basically say that that the data does not exist or whatever, but with this whole FPV like censorship resistance, they can be certain that they've actually downloaded all the data, and if they haven't, then it's obvious that they're missing something. So another aspect that we're trying to include, and one thing I've given many talks over, is actually on-chain governance. So right now, most smart contracts and such don't really have a governance in place. They might have like, an owner, an upgrade path, or things like that. But on-chain governance is a lot more complicated than that and a lot more powerful than just saying, okay, this certain address owns this contract. You can actually have like a set of board members or whatever that own the contract. You can transfer that ownership without having to hand over any private keys and potentially, exposing your users to risk. And you can use it to facilitate upgrades. And you can even do it, like in a completely decentralized way, such as like with token voting or anything like that. And but we plan on including this as like a first-class citizen, basically, in the quantum blockchain when you're using the x86 VM. It'll be basically the equivalent of like a pre-compiled contract that you can just say like include governance, and you instantly have something that your developers and everything can use to prepare your DApp or your smart contract for the future. We're also making this enterprise ready. And so we have another version of Quantum called Quantum X that's basically our enterprise private permissioned version of Quantum. And we'll be, of course, including the x86 VM into that version of Quantum as well. And where it gets really interesting is, you could have a big company like Amazon. They probably wrote their accounting code maybe in like 2007, 2005, or a long time ago, before smart contracts and blockchains were even a thing. They can actually take that existing code, such as like code written in C++ or Go or anything like that, and bring it into the blockchain and run it as a smart contract. And basically, they're able to take their various pieces of infrastructure that need some kind of decentralized component in it, and basically bring it into the blockchain and run it as a smart contract, so that instead of running Solidity smart contracts, you're running this old archaic system written in C++, but on the blockchain, and maybe you had to fix a few things to make it work, but you don't have to rewrite the entire thing in a completely new language, find completely new engineers that even know what Solidity is and all of that, and use like different tooling and everything else. You can use existing tooling, existing compilers, and basically whenever you need to also modify the x86 VM, like you say you need like some special feature that we didn't include for whatever reason, then you can actually, as a company, go and take that that source code for our virtual machine and extend it, do whatever you want with it, and of course you can choose to make it open source and give it back to the community or whatever, but you don't have to. That's one of the biggest problems with like enterprise Ethereum type stuff, is that it's GPL licensed, which basically means if you make any changes to it, you have to publish those changes to the community, like basically if you're using it. And so that can be like a big problem for companies putting like trade secrets and things into their blockchain. And so QuantumX and thus the x86 VM and everything will be like liberally licensed, so that you can choose to release the source code if you like, but you don't have to. And so Quantum, of course, is not alone in trying to basically bring some of these features into blockchains. Things like new programming languages or existing programming languages, and also like existing tooling and things like that. The biggest one, or the biggest competitor, I guess, will be like WASM or WebAssembly. And so WebAssembly is still very young. It didn't exist a few years ago, and the design on that, like the specification for how to properly implement it, isn't considered complete yet. So there's still like more work to go. So thus, like, we kind of think, yeah, it's like it looks awesome and it's really exciting, but we also don't want to bet $1 billion platform on this technology that's still considered alpha or beta, or like basically not production ready. And so in the future, I expect that we'll end up including support for WASM eventually. But right now, the all of the tooling and compiler support for it is still very new. I think like LLVM and Clang and like all that, it still considers it like a beta like release for like how far their compiler is. And also another problem with WebAssembly that could affect a lot of different projects in the space is that there's no smart contract representation on the design board. Right now it's like Microsoft, Mozilla, or Google, all the browser manufacturers. That's who controls where WebAssembly is heading and what the final design is going to look like. So smart contracts aren't even being really considered for that. There's no representative on that design committee to actually say, oh, this won't actually work on smart contracts. Like, this is going to be a serious problem. We can do this easy workaround or whatever, but like, we can try and keep everything compatible. So in the future, there could be like WASM for browsers and WASM for blockchains or smart contracts. And like, one of the big features of WASM is that it brings all this compatibility to the table. And if you have to have two separate versions of WASM that each have their own different compilers, own different tooling and everything else, you'd lose a lot of the benefit by even integrating that into your blockchain. And so I definitely think like, in the future it could be really interesting, but right now it's still immature. There's still too many unknown variables. And at least at Quantum, we've always been very risk averse. And so, we've in the past used existing technology that's, not as shiny as inventing our own stuff, but we use existing technology that we've seen work already. For instance, like our proof of stake algorithm is actually like 3 years old, I think. And like we didn't invent it. We did like, make some slight modifications, but the actual like algorithm and everything has been like tested in other blockchains. We know it's secure, so that's what we used. Same thing with like the x86 VM. There's already like a million different x86 VMs. They're called things like Hyper-V or VirtualBox or VMware. Like this is an existing space. People are already like have the same technology, just not specialized for blockchain applications. And so basically we're hoping to, instead of inventing everything ourselves, to actually take some of the pieces that have already been invented and bring them into blockchain, because right now the blockchain and smart contract space really needs more stability rather than more shiny toys and features. So that's where I think like that a lot of projects need to kind of look at, is using existing things that exist rather than writing a new white paper and implementing something completely new that maybe isn't even necessary. Anyway, yeah, thank you, and yeah.